Arrays are easy to use, and of course you use arrays all the time in Java. But to use an array, you have to designate the size of the array in advance. Now, suppose you're reading a large file of words and collecting all of the words that contain E's. Or suppose you're reading from a network socket and storing all the strings that the client at the other end sends you. Or suppose you're looping down all the departments within a company and collecting a single list of all the company employees. In all three of those cases, even after you've added some items to your list, you don't know how many more are coming. So you can't use arrays. The solution is to use lists. And Java gives you two versions of lists, array list and linked list. They're very similar, and both of those stretch as you add items to them. In fact, they're so similar that most of the operations are the same method names, and array list and linked list give you the same output for the same operation. The only reason Java gives you two is because of performance. There are certain operations that are faster for array list, and there are other operations that are faster for linked list. All right, let's look at the most basic list operations, starting with how you create a list. To make a list, you say list. You give the type like string or employee or capital I integer in angle brackets. You make up a variable name. Then you say new. You give the concrete type like array list or linked list. You use empty angle brackets, and then you supply the constructor arguments. There are some possible constructor arguments, but most of the time the argument list is empty and you just put empty parens. Now, there are lots of things new here. There's a lot of pieces of syntax that we haven't seen before, so we need to look at them one at a time. The first question is, why did we use the word list here, yet the word array list or linked list on the right-hand side? So for example, we could say we have a list that can only contain strings. We'll name the variable names, and we'll make it an array list. Why did we say list here, but array list here? Or we might say we have a list of employees. We'll call it company workers, and it will be a linked list. Well, that's the same question. Why did we say list on the left-hand side, but linked list on the right-hand side? Well, recall back when we were doing the example where we wanted to make a static method that took an array containing circles, rectangles, and squares and sum up their areas. The best solution that we came up with was to make an interface called shape. And then we had circle, rectangle, and square implement the interface. We declared our array to be of type shape array. And the benefit that it gave us is that Java knew ahead of time that all shapes have a getArea method. Well, it's the same idea here. List is the interface type. Array list and linked list both implement the interface. And it's important that you plan ahead for changes. The major difference between array list and linked list is performance. Almost all of the methods of array list are shared with linked lists. Same method names and exactly the same behavior. So that if you swap out an array list and you replace it with a linked list, your method calls stay the same and your output stays the same, but you might change your performance. But even though most of the methods are shared between array lists and linked lists, it's not true that all of them are. There are a few methods that are specific to array list, and there are a few methods that are specific to linked lists. And you want to hedge your bets. You want to start off with, say, an array list, but make it very easy to come back later and change your mind for performance reasons and switch it to linked list. If you had said array list here, or you had said linked list here, then later on in your code you might have accidentally used a method that was specific to array list or linked list. And then if you wanted to change your mind later and for performance reasons and switch the array list to a linked list or switch the linked list to an array list, your code would no longer have compiled because you used an array list specific method or a linked list specific method. Now there aren't very many of those methods, but there's a few, and you want to make sure you don't use them accidentally. So it's a very well accepted practice that you declare your variable to be the interface type. Then it's not possible to call a method on your variable that's specific to array list or linked list. Now, if you change your mind, again, you change your mind for performance reasons, you just erase the word array list on the right-hand side, you replace it with the word linked list, all your code stays the same, your output stays the same, but your performance can possibly change. All right, so that's the first point, using the interface type to declare the variable, but using the concrete type when you actually give the instantiation. The second is this funny angle bracket thing. We haven't seen that before, and that tells Java to check at compile time the type of the object that you put inside. Underneath the hood, lists, both array list and linked list, actually use objects as their type. But by putting this type in angle brackets, these are called generic types, Java checks at compile time that everything you try to insert into the list is really of that type. And then when you take something out, it knows ahead of time what the type is, and so you don't have to do a typecast. So down in this example here, I say I have a list that can only contain strings. Java will now check at compile time, not at runtime, so it doesn't hurt your performance, that everything you try to insert into that list is actually a string. Similarly, if I say I have a list of employees, then Java checks at compile time to verify that everything you try to insert into the list is really an employee. So this is a great benefit. It makes your code much more type safe, and it doesn't cost you anything in runtime performance because all the checks are done at compile time. All right, so the first point is you use the interface type list. The second point is these element types in angle brackets. And the third point is this funny empty set of angle brackets here. So in Java 6 and earlier, you had to repeat the type there. So you would have had to say list that can contain strings names equals new array list, and then in angle brackets you'd put string. But starting in Java 7, they made the compiler smarter, and it does type inferencing, and it realizes that you are using a list of strings, so it must be an array list of strings, and you don't have to repeat it. That empty set of angle brackets is sometimes called the diamond operator. You still have to put it, otherwise Java will think that you just want to have arbitrary types and use object. But you don't have to repeat the type inside the angle brackets here. Okay, so the most important thing is how do you make an empty list? The next thing is how do you put something in it? The most common way is to just call add. And you supply a value, and Java just sticks that on the end of the list. Of course, if you said it was a list of strings, Java will check to make sure your value is really a string. And again, a string that at compile time, not runtime. If you said it was a list of employees, it'll check that it's employee. You can also insert it at an arbitrary location. Rather than just sticking it on the end, you can say, stick it in the third location, or stick it in the fourth location, or stick it in the 187th location. This does have some performance implications that we'll discuss later, but occasionally you want to stick it, in particular, sometimes you want to stick it at the beginning, and you supply an index of 0. Okay, so you make a list, you add something to it, and then you can retrieve an entry. Now, sometimes you just loop down the list, and so then you don't have to call get explicitly. You just use the Java for each loop with the colon. But sometimes you want to say, give me the 14th entry. And so then you say get, you supply an index, and it returns the item at that index. You need to know the size ahead of time. If you ask for the 14th entry, and there is not a 14th entry, then you get an exception. All right, let's try out some of these basic operations. Now, list, array list, and linked list are in the java.util package, so you need an import statement. But most Java developers don't explicitly type in that import statement. If you're like me, you just type in the line list string entries equals new array list, and immediately Eclipse puts a little red X on the left-hand side and says, I don't know what those classes are. But right next to the red X is a little light bulb. You click on the light bulb and it says, would you like me to fix it for you? And the first thing it suggests on how to fix it is, would you like me to add the right import statement? So most Java developers don't memorize the packages that the classes are in. They're kind of somewhat familiar with them, but you don't need to memorize them. Now, in the case of java.util, that's used so frequently that most Java developers have kind of remembered it because they've seen it so many times. But you don't need to make it a priority to memorize all the packages. Eclipse will help you in that regard. All right, then we say list, not array list, list. It can only contain strings. We make up the variable name. We choose either array list or linked list, empty, angle brackets, and most of the time empty constructor arguments. So now we have an empty thing that can contain strings and will stretch as we add things to it. Now, let's go back and think about why did we use a list instead of an array? And the answer is so that it will stretch. Even after we've added some elements to it, we don't know how many more are coming. So here's an example. I'm flipping a coin. I'm rolling a 10-sided die. And if math.random, which returns a number between 0 and 1, is greater than 0.1, keep going, otherwise stop. So 90% of the time I keep going, 10% of the time I stop, but I don't know how many times I'll succeed. It might succeed 0 times, it might succeed 1,000 times. So even after I've added a few entries, I don't know how many more. That's the time to use a list. If you can figure out how big it is ahead of time, you can use an array instead. All right, then I add things to it by using add, and Java will check at compile time, not at runtime, at compile time, that it can verify that the argument to add is a string. And since Java knows that everything is a string, when you take things out, you don't have to do a typecast. Java already knows that it's a string, even though internally it's storing it as object. So I can do the for each loop, and I can say for each string named entry in entries, do something with it like print it out. So I don't know exactly what this output is going to be because it's somewhat randomized, but here's some representative output. So we looked at the 3 most basic list operations: instantiating a list, inserting something into the list with add, and retrieving something from the list with get. Here are a few more of the most basic list operations. See if something is in the list. Contains. Contains returns a Boolean, yes or no. Remove something. You can say remove the thing that is at this index, or you can say remove this particular item. If you try to remove something at an index and the index is not there, you get an exception. If you try to remove an element and the element is not there, it's just ignored. I can find out how many elements there are with size. And again, it's like the length of an array. If the size is 12, the indices for get are from 0 to 11. And here's a very useful feature. The list interface, all entries in the list interface, array list and linked list, have a very readable toString method, which means you can pass a list to print. And it'll automatically print it in a very readable form. It'll put square brackets around it, and then it'll print out the individual elements, and it'll put commas in between. So you don't have to loop down a list in order to print it out. You can just take the list object and pass it to print or print line. That's very useful. Okie dokie, let's try some of these operations. I can make an array list, but by making the variable of type list, I can change my mind later and switch it to linked list and guarantee that none of the rest of my code has to change, and also guarantee that my output is the same. I can add a few entries. I can look up the size that results after I add those entries. I can retrieve an entry. Remember that an index of 1 means the second entry. I can do a test. Does it contain a certain entry? I can remove something and then see the updated size. And when I run this, you see the output. But if I switch array list to linked list, none of my code changes, and the output is always guaranteed to be exactly the same. As long as you use list as the type, then none of your code changes, none of your output changes. The only thing that might potentially change is your performance. And so that's what we need to discuss next.